In this problem on bank capital adequacy, it says regulators estimate that a certain bank will report a profit that's normally distributed with a mean of $600,000 and a standard deviation of $2 million. And then the question here is how much equity capital, primarily tier 1 equity capital, in addition to the bank's existing capital of $5 million, should regulators require for there to be a 99.9% chance of that capital amount not being wiped out by losses. So in essence, in this problem, given this confidence level, there is only a 0.1% chance that the losses will in fact exceed this capital this amount of capital. So the question here, back to it, says how much equity capital, how much more equity capital will the bank really require? All right, so now to answer this question, we really have to consider the distribution of the firm's income. So right here, as a reminder, the confidence interval estimation model calculates the lower limit and the upper limit within which we believe the actual population mean mu lies. So you might recall that the definition of a confidence interval estimation for the population mean is equal to the sample mean x bar plus or minus the z value multiplied by the standard error. Now the product of these two terms right here is what we call the margin of error. So by subtracting the margin of error from the sample mean, we obtain the lower limit of the interval. And by adding it to the sample mean, we find the upper limit of the interval. So for example, for the 99.9% confidence interval, the lower limit would have to be 5.98 million and the upper limit would be 7.18 million, because the z value corresponding to the confidence level of 99.9% is 3.29. So by multiplying 3.29 by the standard deviation, we find the margin of error, which then, when subtracted from 0.6 million, will give us this 5.98 million. And of course, by adding it to 0.6 million, we find this upper limit, 7.18 million. Now, I know that while you may have had confidence interval estimation before in a business statistics course, you might not be all too familiar right away with the z value that corresponds to the 99.9% interval confidence level. So you would recall that the confidence level, if this were to be 90% confidence level, the z value would have been 1.645. If it is 95% confidence level, the z value would have been 1.96. And if it is 99% confidence level, the z value would have been 2.576. So those are the three conventional levels of confidence level. Nevertheless, it's quite easy by going to a statistics book to find the confidence to find the z value corresponding to the 99.9% confidence level. Anyhow, this is not actually the question sought by this problem. We are not concerned by the limits that adjoin the lower the 99.9% confidence level. The question here is, if you go back there, it seeks to find the lower limit of the 99% confidence level. So in this case, we argue, or rather, we believe that there is a 99.9% chance that profits will not be worse than $5.58 million, if these are in millions. That is to say that we're looking at the lower limit. Remember, when you talk about the, when you look at a profit distribution, the left side of the distribution will go into the loss territory. The right side of the distribution will go into the profit territory. So assuming normal distribution, we want to be 99% confident that our profits, that they using profit generically to include uh, operating losses as well as operating incomes. So we want to say that profits will not go below this solid red line right here, will not lie within here, because this tiny area here represents the 0.01%, while the shaded blue region to the right of it represents 99.9% confidence level. So we want to be 99.9% confident that our profits, the outcome of our operating profit would not be worse than this level. So the question is, what is this level? Now, this is going to be a one-tail, a z-value based on a one-tail region. So looking at the z-value for an area of 0.99 to the right of it will give us 3.09, or if you like, that's the z-value that corresponds to an area 0.01 to the left of it. Now I've given this this website right here, which is one of several websites I like to use to quickly find my results. And if we went there right here, right, we can use this first criterion here that says area from a value, and it says use to compute the p-value from z. Well, basically the probability value. So in this example, we have so we want to choose the second one actually, that says value from an area used to compute z for confidence intervals. So here's what we're going to do. The area here that we want is 0.99, 0.999 actually. The mean from this problem is 0.6 million, which is $600,000, and the standard deviation is 2 million. So now we want to get the value that corresponds to the area below it. All right, so if you click on that, actually let's choose area, sorry. So we want to get the z-value that corresponds to the area of 0.99 above it, okay, above it. So that would be right here, right? My apologies. So right here, and the area above it is this 0.99. That's why I had to choose this one above it. So, and the calculated result is 5.58. So actually, right here, that's the final answer. So that website does this whole thing for us. It takes whatever the z-value is, which is 3.09, multiplies it by standard deviation, subtracts it from 0.6 to give us this final result of 5.58. And what this is saying is that the profit value, which of course it's a negative profit here, that would cause us to be 99.9% confident that the outcome, that the operating profit would not be below it, is a loss of 5.58. So the z-value corresponding to that is this 3.09. And so this point marks the worst loss scenario, or if you like, the worst profit scenario, which is really bad profits mean losses. And that's going to be 5.58 million. So we can be 99.9% confident that within this operating period, that this bank's profit would not be worse than 5.58. Fortunately, the bank currently has $5 million in Tier 1 equity capital. So all this bank has to do is to fork out an additional $0.58 million so as to satisfy the capital adequacy requirement, given this worst case scenario. By the way, this worst case scenario can be viewed as the value at risk, the worst case scenario that can exist within a defined period of time. And in this example, based on the confidence level of 99.9%. And this concludes the presentation of this example. If you were to go further in this presentation, you will see a quick review, another review problem here that shows you the financial data of a bank, and then it proceeds to ask you to calculate return on assets, return on equity, net interest income, and net interest margin. Now, additionally, it also asks you to calculate interest rate risk exposure, defined as the ratio of interest-sensitive assets to interest-sensitive liabilities. Now, you may recall that if you look at the difference between these two, you would actually be calculating income gap, which is the difference between rate-sensitive assets and rate-sensitive liabilities. And in this case, where rate-sensitive assets are less than rate-sensitive liabilities, which would cause you to have a negative gap, what this is telling you is that the bank will face certain problems associated with its net interest income if interest rates were to rise. Because if interest rates rise, then you're going to be paying additionally more interest expenses on your liabilities than the additional interest income you'd be receiving on this smaller amount, which means that your net interest income and therefore net interest margin would drop. So the risk here is that the bank will suffer a reduced net interest margin if interest rates were to rise, because it does have a negative income gap, which is the same thing as saying an interest rate risk exposure ratio that's below 1. The capital adequacy ratio looks at your equity capital, the bank's tier 1 capital for the most part, as a ratio of the risky assets of the bank. Of course, the higher this ratio is, the safer the bank is, because it means that the bank has sufficient equity capital to cover any potential losses that can arise from the risky assets that it has. The risky assets are going to be the loans that the bank has made. The operating expense ratio is a straight definition. It's total expenses divided by the bank's total revenues, where total expenses include both interest and non-interest expenses, and total revenues would include interest income as well as non-interest income, such as any charges the bank imposes on the services it provides its customers. In this ratio, it's 1. So this is the threshold. You really don't want this ratio to be above 1. If it's above 1, then its interest expenses are more than its total expenses are going to be more than its total revenues. And of course, from an equity investor standpoint, equity capital ratio is important. Your equity capital ratio is equity capital as a ratio of the bank's total assets. This concludes this presentation. I'm Pat Obi, Professor of Finance, Purdue University, Calumet.